Hi everyone, welcome back. In this final example for this week, we're going to talk about writing sequences. So now that we've covered how to make a synth that can play notes, and we've covered how to get notes from a musical scale and even map note numbers to lower or higher octaves, we're going to combine those two things and we're going to add the concept of a sequence, which is going to be a series of notes that we're playing in a particular order and that we're repeating over time. And then we'll build a little sort of generative, riff creator based on that idea. So let's just dive into it. Now, you'll notice I'm starting from the previous example. So just like I did before, I'm going to duplicate this and let's call this one sequence. So just so we're not starting from scratch every time. And yeah, so this is where we were at, right? We had an array called notes, and that array contained all the notes of a C4 major scale currently. And when we press the mouse here, we use this mapNote function that we developed so that we could provide numbers that extend beyond the range of indices, the normal range of indices of the array, which normally would just be 0 to 6. We could go negative or positive, and that would expand the number of notes available across different octaves. Put on my headphones so I can hear what's happening. Yeah. So this is where we were at in the previous example. Okay. Now, another cool thing we can do with Tone.js is we can create sequences and we can create loops. And we can create something called patterns. So let's take a look at the documentation here. We're going to scroll down here. So there's these thing called events. So Tone.js has something called a transport, which is basically like a clock. And you can create events that are going to be synchronized to that clock. Very useful for creating musical programs. You can create parts and you can build sequences out of parts. So maybe you can build up rhythms and things like that. In today's example, we're going to focus on the pattern object. The pattern is basically what's called an arpeggiator. So it takes a sequence that you give it, and then it's going to arpeggiate, which means move through the sequence based on different patterns that are available. Okay? So we're going to talk about the syntax on how to create a pattern. You'll be able to specify the rate of that pattern, so the time interval at which it's moving through the sequence, a sequence of notes we want to play through, and excuse me, different pattern types. Okay, so let's see pattern types here. Where do we see that? Just to show you the different options, the pattern type. See tone control dot pattern. Can we see it from here? No, that's the source code. Where is the list of pattern types? Is it pattern name? Oh yeah, okay, there they are. All right, sorry about that. So the different pattern types for arpeggiator are going to be things like going up. So that's going to be cycling through the sequence and then going back to the beginning, playing the sequence backwards. That's down, up and down. So moving up and down the sequence, down, up, alternate. So alternate between notes, random. There's a random mode, random once, which will play through the sequence, but make sure that it hits all the notes before starting over. And random walk, which is random, but only moving from one note to the next and not jumping all over. Okay? So this pattern object is going to allow us to take a sequence, play it based on the clock, based on the tempo, and we'll be able to specify the types of arpeggio we want to get from that sequence. So let's create a pattern object and see what the syntax looks like to create that pattern. So I define a global variable called pattern up here, and we will go into initialize audio and say new tone.pattern. Now the parameters, there's three parameters we need to provide at the very least to the pattern object. The first one is going to be a callback function. And here we're going to use the syntax where we define a function right there in the parameter list. And that function is taking two parameters. The first one is going to be a timestamp because this will tell our synth when to play the note that we want to hear so that it's in sync with the clock. And then the second function is going to be the note in our sequence where we're at. So we're going to call that, the second parameter, we're going to call that note. Okay? So this is how we define a kind of an inline callback function. Right? So the first parameter is actually a full function here, and we'll put the body of the function here in a second. The third parameter is going, the second parameter is going to be the array of notes we want to play. So let's just start with putting our notes from our scale, okay, just as a starting point. And then the last parameter is going to be the pattern type. So we'll just go with up to start with. Okay. So there's, again, a few options, up, down, and so forth. We just looked at them in the documentation. So what happens with the callback is that the tone pattern, right, is going to be playing at a certain interval, and it's going to run the code that we specify inside this callback function so that it's going to be on time with the clock. So inside this callback, we could say, we know we have a synth object right up here. We're going to say synth.trigger attack release. You're going to play the note that is the next note in the sequence. We're going to receive that note as a parameter to the callback. And we're going to say how long we want that note to be. Let's make it an 8th note for now. And the time parameter, which we didn't put in before when we used the synth variable, or the synth object, time parameter tells the synth when to trigger that note. So a time of 0 means right away, but you can sort of schedule notes to play in the future. And that will, this will take this parameter of the callback called time. We don't know what that number is going to be, but sometimes, like, because in practice, like, these functions, they don't run in parallel, they run sequentially. The way the scheduler works is that it calculates, when to schedule everything so that the notes play together at the same time. Okay, so Tone.js takes care of that, all of that clock stuff behind the scenes. And then once we created the pattern, we can start the pattern. Okay, we're going to say pattern.start. And we can also give it a time when to start. A 0 would be at 0 second, 1 would be 1 second in the future. And let's just put, and if we put nothing, it's just going to be 0. Now, if we just start the pattern, here I'm just getting my note press here, my mouse press. Let's get rid of this. Actually, we don't need that for this example. If we just start our sketch here, nothing happens, is because we started the pattern, but the overall master clock has not been started. So if you've ever worked inside a digital audio workstation or a DAW, you will be familiar with this concept of a transport. That's the thing that handles the time, the clock. So tone as a transport object, and we need to hit play on that transport in order for things like patterns and sequences and loops to also start playing. So you can hear what our pattern is doing right now. It's playing through our notes array that we've provided it. It's doing so by default. I think it's quarter notes, but I'm not sure. And then when it gets to the next note, we get to run a little bit of code inside this callback that says play the note using the synth. If we want to make the pattern go faster, we can change the interval attribute of the pattern, and we can set it to a different time interval. So this is different from a note interval. These are time intervals. So for instance, we can say play 16 notes, or maybe let's start with 8 notes to see if my theory was correct, that the default is quarter notes. So it was playing 8 notes. Let's play 16 notes, and then let's make our sounds like shorter, even like 30-second notes. Right? Oh, and it would help if I did not misspell interval. So let's make sure we spell it correctly. Right. So we can play faster. We can play slower. Yeah, so I was right. The default is 4 and quarter notes. And we can play with different pattern types, right? So down would be playing backwards. We can do like up, down. So you get the idea. So it's pretty useful. The pattern object, basically an arpeggiator or a way of playing through a sequence in a particular order and just repeat that process over time. Now, this is nice, but you don't always want to be playing all the notes of a scale all the time, because that gets a little bit boring. You're just basically playing scales, like this. Not super interesting. So we're going to take advantage of the fact that, we have this mapNote function, and we talked about in the previous video how we can think of the notes as not just the notes in the scale themselves, but just as note numbers. Okay? So instead of providing our pattern with an array of notes, which is our full scale, we're going to add one more layer to this. We're going to call this the sequence. And the idea behind the sequence is that it's going to be an array of note numbers that we want to play from our scale. Okay, so for example, if we wanted to play a C major seventh arpeggio, we would select these notes. We would take the first note, the third, the fifth, and the seventh note of the scale, and play these note numbers as opposed to the actual notes from the scale. Okay, so this becomes, we can select which notes we want by specifying note numbers. Okay? So we're going to use this sequence as the thing that is driving our pattern instead of the whole scale. Now, if we do that, we just have to remember that this now really, we're going to change the callback to call it note number, which means we can't just play it. We have to say notes, note number. Okay? So the thing we're going to be getting as we cycle through the arpeggio is no longer just going to be a straight up note when we went through our scale. It's going to be a note number. And we can use our that as an index into our notes array. Okay? All right. Now, this is great if we stay within the 7 notes of the scale, right? But if we want to go further, like let's say we want to go and add, the octave on top, right? Then what we're going to have to do is we can't simply use note number as an index directly because there is no note 7, right? We only have index up to index 6 inside our scale. So we are simply going to use our mapNote function. We'll say, take this note number and give me a note based on this scale, but mapNote takes care of the notes that go further and lower. And then we'll pass in this note variable to the synth. All right. So now we can play specific notes from our scale, not all of them, right? And we can define that as a sequence. Let's make those into 8-note duration as well. You may recognize that little riff from Stranger Things. It's just a C major 7 arpeggio being played up and down. Okay? So really fun. Now, we have a pattern, right? We're able to play a sequence. So this is nice. So now we could also start to bring in, and just to demonstrate again, like we could make this, we could go to any note, right? We could add some more notes in the sequence. We can go negative, right? When we go negative, we're going to go to lower notes. Maybe we go like negative the other way. Anyway, so we have the ability to put in negative note numbers because we created this mapNote function in the previous example. If we wanted to make this a little bit more, say, generative, we could simply say, let's define the sequence randomly, okay, as a starting point. Maybe we could do this in setup. Just kind of thinking ahead, we might want to recreate that sequence as the program runs. Let's create a function here called generate sequence, and its job is going to be to create a random sequence. Okay, we could say start with an empty array, and then come up with a number of notes we want to see in that sequence, maybe anywhere between, let's say, 3 and 9. And then we're going to write a for loop that's going to count based on that number n we just came up with. And we are going to put numbers into that sequence that are going to be random as well, maybe spanning 3 octaves. Okay, and here I'm using the floor function to round down to make sure we keep using integers. We don't need decimal point values here. And then we could throw this generate sequence, maybe at the start of initialize audio. We could also do it in setup here, but it doesn't really matter. Let's save, and so now we're getting a random sequence, right? Every time we restart the sketch. So kind of cool. Obviously, we could get more sophisticated about how we generate that random sequence. Just random notes are never going to be super interesting. Things to try, you could try Perl and noise as a way of, creating a little bit more structure in your note progression. You could take advantage of some knowledge of intervals to create interesting melodies. For example, if you jump in steps of 2, often that will give you interesting kind of chords, arpeggios for chords, the way we did originally, like in our test sequence here, we had a 0, 2, 4, 6. So 0, 2, 4, right? These intervals give us we're jumping in steps of 2, and that gives us a major chord, and then we can add a flavor to it. So depending on where you start, you can follow this pattern to create different arpeggios. So that could be fun. What we're going to do in this example is we're going to play with the idea of layering patterns. So we can play multiple patterns at the same time. And a really cool kind of somewhat generative idea that I really enjoy comes from a piece of software called Fugue Machine. This is a sequencer for iPad. It's a MIDI sequencer, and the concept in Fugue Machine is that you have one sequence, but then you can have multiple tracks who are playing that same sequence at different speeds, maybe using a different pattern, a different arpeggio pattern, maybe using a different transposition, right? So the same sequence might be played an octave lower or an octave higher. So we're going to kind of steal that idea here a little bit and create our version of that in P5.js. So what that means is we're going to take the concept here that we have of a pattern and a synth, and we're going to bundle these two things together in something called a track. Okay, I'm going to call it a track. You could think of it as whatever you want. These are just words I'm coming up with. And we're going to use the class syntax to bundle these things as a track. The reason I'm going to use the class syntax is it makes it a little bit easier to write the code that way. So let's do this, and I'll review the class syntax as we go along. Okay. So we'll leave these here for now because this is our test program. Let's take the ideas we developed here and package them into a class. The reason we want to do this is because this is going to allow us to create track objects, and a track will have both its own synth and its own pattern generator. Okay, so its own pattern sequencer. So they're all going to play off the same sequence, but they can play at different times. And of course, we want different synths, so we can play different notes at different times. So we're going to write a class called a track. And it's going to be a very simple class. And the only thing we'll put into this class is the constructor. Okay. So this is the syntax for this. This is another way. There's a lot of different ways in JavaScript that you can define objects. We've used simpler notation before, where we just simply use the curly bracket notation. The class syntax has some advantages that will make programming this track a little bit easier. So the constructor is the function that we're going to call whenever we create our track. So now that we have this class, let's get rid of these variables here. We're going to be able to have a track, okay? And in the initialize audio, we are going to be able to create our track. We'll be able to say new track, okay? And now we're going to take these and we're going to bundle them into the track class. Okay? So for simplicity, I'm going to cut this so I don't have to type it all over again. And I'm going to paste that in the vicinity here of my track. Let's paste it in the constructor. Okay? Now, when we are writing code inside a constructor for a class, if we're defining variables that are going to become attributes of the object, we have to use the keyword this. So the keyword this means I'm building a track object here. And so this track object is going to have a synth variable inside of it. So we're going to prefix it with this. You can think of it as, it's a kind of apostrophe S in English, or it means mine. right? My synth, my synth will be this synth object I'm making now, and it will live inside this track object the constructor is returning. We will do the same with the pattern. And when we trigger the synth here, we will say this.synth. Now we're gonna, if we just leave it like this, it's not gonna work. We'll explain why in a second, but we'll come back to that. Okay? And we'll say this.pattern, this.pattern.start. Okay? So what I've done is I've bundled both the synth and the pattern inside this constructor function that's going to return an object with both of these objects contained inside of it. Now, there's like a really important little detail here that the class syntax makes. The reason why I'm using a class here and not just another way of creating the object. And it's going to be about how we define this anonymous function over here for the callback. If I write the function like that, this is a little bit of a tricky concept to wrap our heads around, so I'll try to explain it the best I can. If I write the callback like that, when I refer to the keyword this, okay, this is kind of like it's a dynamic keyword. Its meaning changes based on the perspective of the code at different parts of the execution of the program. If we write this inside the callback here, what the keyword this will refer to is not our track. It's going to refer to the pattern object, okay? Because if you think about the scope of the code being this kind of like nested, Russian doll metaphor, at this layer in the code, we are defining something that's inside this pattern object. Okay? So when we say this, it's going to refer to the pattern, not the track. It's a problem because I want my pattern inside this track to play the track synth, right? And the pattern right now doesn't have a synth. Okay? The track does, but the pattern doesn't. So what we can do is we can use something called arrow functions in JavaScript. The syntax for arrow functions look like this. We are going to start with the parameters, and then we are going to put an arrow like this. It looks like an arrow. It's an equal sign and a forward equal sign and then a greater than sign. So this way of declaring a callback means that the scope here is going to be overwritten. It's going to go back all the way to the level of the class. That's how I like to think of it. So that now the keyword this here is going to refer to the track and not the pattern. It's a little bit kind of like getting into the minutia of JavaScript for the level of this course. But so you can just use it as such when we're creating the pattern. But this is the reason why I'm changing here the syntax of declaring this callback function. And you'll notice that in a lot of the examples from Tone.js, they use also this arrow notation. Okay? And in the pattern example we first looked at, if you were paying attention, this is how they declare their callback functions. So that inside the callback, you can refer to things that are not necessarily from the perspective of the pattern object itself. So it's all a matter of perspective. Think about where you are in terms of where the code is at and where it thinks what it thinks the keyword this is referring to. So that allows us to kind of break out of this scope and refer to the track. So now we can say, oh, the synth from the track, right? And other variables from our track as well. So now we have a sequence that's playing, and this sequence is now playing based on our track. Okay, note that, let's move that up here, although it doesn't really matter. This is based on our track, right? Let's stop it. Not the most beautiful sequence, but it's okay. We're going to make that more interesting in a second. So our track now is able to play this this pattern, right? And the other thing we might want to do here is give our constructor the ability to specify, different attributes of our track. Okay? So the goal here is we're going to eventually create a second and maybe even a third track, and they're all going to play the same sequence, right? From mapNotes, based on the same sequence over here, but they might have a different pattern, right? They might have different note length, and also they might run at different speeds. Okay, so let's define those as parameters to our track constructor. So the other thing we might want to do that might be fun is add transposition, right? So when we play our note here, right, the note number, it might be fun to shift it, maybe shift it by a certain number of semitones. So that, for example, we can play one sequence will be at one pitch, and then the other sequence, maybe that's going to be the bass. We're going to lower it a full octave or 2 octaves down. So that's going to be the concept of transposing. So let's put some parameters here, and we'll put some default values as well, so that if we don't specify anything, that's just going to be the default. So let's assume we don't want to transpose the sequence. We'll say equals 0. We're going to set a note duration. Our default is going to be an 8 note. We're going to set a time interval of 8 notes as well, and a pattern type. Close this here so we can see everything on one line. Pattern type, maybe the default will be up, okay, instead of up down. And then we're going to use these parameters. We're going to use these parameters and specify, when we create our pattern object, instead of 8n, we're going to say interval, right? Node duration. Now, node duration, we need to access it inside this callback. So that means we need to save it somewhere so that we can recall it later. So we'll say this.node duration equals node duration. So node duration is coming in as a parameter. We're going to save it on the object here. And then we can use it here instead of always doing the same thing. If we want to transpose, this would happen here. So when we map the note, we could add an arbitrary offset to that note number, and this would become the transposition amount, how much we're shifting the whole sequence up and down. So just like the node duration, because we need to access it inside this callback, we are going to save it first and take the parameter, save it into an attribute of the object, and then we can refer to it inside this callback, which will run at a later time. And what's the other thing we set? Oh yeah, we have a pattern type. Right? So instead of up down, we're going to say pattern type. Notice I'm not saving these as variables because I don't need to. Once the constructor is over, this has been set and this has been set. So only these two I saved as internal variables because I need to recall them when the callback comes around. So now we have a track that we can use, we can create, and we can affect its initial parameters. For example, we could say, let's set a transposition of 0, but you're going to play 30-second notes at a 16-note interval, and you're going to play up-down pattern. Okay? So now we're getting whatever the sequence was that we generated, which, we could take a peek at it, and let's throw our console.log here, just so we know what we're dealing with. After we generate the sequence, yeah, so this is the sequence we created, right? It's random. And then what our track object is doing is arpeggiating through it. Now, the beauty of having this as a class is that we can clone this. We can create copies of this track. And this is where the fun part comes in. Instead of having just a single track, we are going to have multiple tracks. So let's make that into an array. Just in case down the road we want to do fancy things, maybe like decide to now we want to draw what the tracks are doing, we could do that more easily. Let's get into good habits. Instead of creating track 1, track 2, and track 3, let's make an array of tracks. Okay, and in our initialize audio, we are now going to say, let's say track 0. Track 0 is going to be like just our baseline. Okay, so track 0 is going to be 8 notes. Okay, and it's going to go up, right? Just very vanilla. And in fact, this is the default. Okay, so I could also just put in nothing, and that would work as well. But now we can also create another track. I'm going to make track 1. Track 1 is going to be, let's say it's going to be our bass. Okay, so track 1, we're going to transpose it by 7 notes in the scale. So that's going to shift the whole pattern down by -7. It's going to take it down 1 octave lower. We are going to make it slower as well, right? So our bass track, we're going to say maybe it's going to play notes for an entire bar, right? So 1 no division, essentially, just one. And these notes are going to play for the full length as well. And maybe the bass, it's just going to go up as well. Just follow the same melody. Let's see what that sounds like. All right. Now it's a little bit hard to hear the bass here because we have such like a big range of notes in our random sequence. So why don't we make that a little bit more constrained? So instead of having a random sequence kind of go all over the place, we're going to keep these random notes between 0 and 6 here. So remember, I say 0 and 7, but because we're taking the floor, the actual outcome is going to be between 0 and 6. Yeah. So this is our sequence now. And let's make the bass even lower then. Let's go -14. Nice. So now what's happening is we have one track playing through the sequence, right, doing up, and then the other track is playing through the sequence, but it's playing 8 times slower, right? And it's shifting the sequence by 14 notes down, or 2 octaves. So we can play with this idea. We can add other layers. One thing that's really fun to do as well is, so if we think of it as like this is the base layer. One thing that's fun to do as well to add a little bit of rhythm is to use what's called triplets or dotted notes. So triplets basically say, here we're going to put some triplets. Maybe they're going to be shorter. I don't know. Maybe these are going to be like 16 notes. Just play a little faster or something like this. Or maybe they're play at the same rate. Now let's play them at the same rate, and they're going to just be shorter in time. Okay? And the triplets are going to be maybe play up and down, just to show we can have different layers. Okay. And if we want to do triplets, in the time interval here, what we can do is add a dot at the end. So that turns this 8th note into 8 dotted notes. And instead of thinking of the time divisions in terms of dividing in 4, it creates triplets. So that's going to create a little bit of syncopation. That could be fun. So it's the same sequence, right, playing, but one of them is playing 8 notes, the other one is playing 8 dotted notes or triplets. So now there's a little bit of a kind of more interesting rhythm happening. We could also like do something like, I'm going to take these triplets, I'm going to transpose it all by, let's say, 4 notes up, right? So we get some harmonies. So anyways, so this is kind of the idea of the Fugue machine, right? So we have one sequence, one pattern, but we have different playheads, basically, kind of playing the same sequence at different speeds, right? Using different note durations, using different transpositions, and using different patterns if we wanted to. So you can really explore this to see the kinds of generative melodies you could create. And of course, we can, change the whole flavor of this by getting a different scale to begin with, right? So now this is a lot like darker, right? Because we switch to a harmonic minor scale. Now this is a repeating sequence, right? In this case, we just have 3 notes that got generated, right? We just have these 3 notes. We're playing 5, 2, 2, but because of the layering of the tracks, we get some interesting melodies happening. There's also the thing that says we can just keep regenerating new sequences. That's the last thing we're going to do to really make this into a fun kind of evolving generative sequencer. We're going to say when we're ready to move on, maybe on mouse pressed, right? We are going to, so when we first press, a melody will get generated, and then in the else here, so that's going to come in the second press and all the other ones afterwards. We're going to call generate sequence again. Now, the only trick here that we have to make sure we do is that once we create a pattern and we give it a sequence, that sequence is actually stored inside the pattern object. So we're going to have to go and update in each of our tracks. We're going to have to update the sequence variable so that it plays the right sequence from now on. So it's very easy. We've made an array for our tracks. So no matter how many tracks we have, we can go through them like this. And then we will say, let's call it track. We'll say track.pattern. And the variable that contains the sequence inside the pattern object is a variable called values. This is the values that it's sequencing over. We're going to make that equal. So update the sequence for the pattern objects. Okay? So unless we do this, we can generate a new sequence, but our pattern won't know to start playing these new notes. So now I can get these random sequences, and every time I click, I can change what the sequencer is playing. I can move through another randomly generated sequence. Right. Not all of it sounds good, but you get the idea. Now, lots of ways we could take this forward and refine what's happening. One of the things that doesn't really change much from one track, like one reset to the next, is we always get these dotted notes. So the kind of the rhythm is the same. We could start to vary that as well by updating the tracks intervals, right? We could change the pattern intervals as well randomly, maybe selecting from a set if we wanted to really mix it up for this. This is almost like the melody line. We could also be a little bit more intentional on how we modify our sequence. Instead of having totally random numbers, we could start with a predefined sequence. And then when it's time to move on, we could maybe just change some of the notes in the sequence randomly, right? So it's not a total departure. That would take us into more ambient territory where we have a slowly evolving sequence over time. So lots of areas to play with here. For your exercise this week, I will encourage you to try different scales, try different arrangements, different combinations of tracks, right? Different pattern types, different playback speeds and note durations, different transpositions to see what happens. And yeah, there's lots of areas that you can explore. You can explore the random generation. You might want to create a composition by making the sequence predetermined and just finding an interesting sequence that creates a fun riff or a fun composition. That could be something cool to try as well. But anyways, we're going to leave it there for this week. The idea was to explore how we can create sequencers within Tone.js and P5 JavaScript. And yeah, how we can start to think of these sequencers in generative terms. So we can use strategies like layering tracks, layering loops, basically, like the same loops, but being played at different scales. And of course, we can straight up generate random notes and have that change over time because we can. Hope you enjoyed, and that will be it for this week. Take care.